When you use an AI like ChatGPT, it feels like there's a tiny, intelligent human living inside your computer, reading your words and carefully thinking about how to respond. It pauses, it explains ideas, it even sounds emotional sometimes. But that feeling is mostly an illusion. Underneath the conversation, there is no little brain thinking in English. There is a giant mathematical prediction engine. Today, we are going to look under the hood and understand how large language models, or LLMs, actually work in exactly 4 minutes. At the core, an LLM is basically autocomplete on extreme steroids. Think about texting on your phone. You type, "I'm on my way," and your keyboard suggests words like home, there, or back. Your phone is not understanding your plans, it is just guessing the most likely next word using statistics from past text. An LLM works the same way, but at a massive scale. During training, it reads enormous amounts of text from books, articles, websites, and conversations. From that data, it learns patterns about which words tend to appear near other words. So when you ask ChatGPT a question, it's not opening a secret database and searching for the correct answer. Instead, it looks at your sentence and predicts the next piece of text one step at a time. If you type, "The sky is," the model calculates probabilities. Maybe blue has the highest chance, while green or falling have much lower chances. It picks the most likely option, then repeats the process again and again, thousands of times per second. But there's an important catch. LLMs don't actually read English. Internally, they only work with numbers. That's where tokens come in. A token is a chunk of text that gets converted into a number. Sometimes a token is a full word. Sometimes it's just part of a word. For example, the word apple might stay as one token, but a longer word like hamburger could be split into smaller chunks like ham, burr, and jur. Each chunk gets assigned a numerical ID. When you type a prompt, the AI first chops your text into tokens, then converts those tokens into numbers. Those numbers go into the giant math engine, which predicts the next number most likely to appear. Finally, the system converts the numbers back into readable text. So the model is never literally handling English the way humans do. Under the hood, it's processing streams of numerical patterns. Now, here's another important piece: the context window. The context window is the AI's temporary working memory. The easiest way to picture it is as a whiteboard with limited space. Everything you type gets written onto that whiteboard as tokens. But every model has a hard limit. If the whiteboard can only hold 4,000 tokens and you paste in a 5,000 token document, something has to go. To make room for new information, the model starts erasing the oldest parts first. That's why AI sometimes forgets earlier instructions or suddenly loses track of the conversation. The information is not hiding somewhere deep inside its mind. It has literally been pushed out of the active workspace. This is also why long chats often become messy over time. Eventually, the original instructions disappear from the context window entirely. Starting a new chat gives the model a clean whiteboard again. So, to summarize, an LLM is not a digital person trapped inside a machine. It's a massive prediction system. It breaks your text into tokens, converts them into numbers, stores them temporarily inside a context window, and uses probability to predict the next chunk of text. And it does this so smoothly and so convincingly that our brains naturally mistake statistical prediction for genuine understanding.